Okay. So what I saying? Which topic? Multiple integrals. Okay, let's work it out. See, as we develop partial derivatives for multiple variables, the same integral concept applied for multiple variables is known as what? Multiple integrals. Okay. Now let's focus on that, how to work it out. Now, there are two types of multiple integrals. One is what? One is what? Double integral. The other is what? Triple integral. So let's start with double integral. Okay, double integral. Write down heading double integration. Okay. Now guys, what is a general double integral? General double integral looks something like this. Double integration of f of x comma y into dx dy, and integral will be defined in some sort of a limit. Okay. Multiple integrals can be operated only in some sort of a limit. We cannot operate in the indefinite manner because this idea is very tedious to handle. Okay. So the only way of solving multiple integrals is we need some sort of a definition. So for definition, we need some curves or functions defining what? X and y. That is, to relate x and y, we need some function. So let us call that as some curves or surface. Got the idea? So that's how we connect x comma y. Now in triple integration, what will now? First of all, what is the interpretation of double integration? What is the interpretation of single integration? Area, right? So single integration is area. Then what is double integration? Volume. How to understand this is dx dy is area. Just think dx dy as what? The elemental area. Area into this function is acting like a height. So area into height is what, guys? So double integration including function is a volume. But if I reduce the function to 1 unit, it becomes an area. So when it becomes an area is, if I write like this, this is when it becomes a double integration as an area. So here what I'm doing, I'm reducing that function into what? One single unit. I'm neglecting the effect of the function, which is acting as a height. That's why it is becoming the area. Are you getting the point here? Every term, every student think that double integration generally is a area. Not this special case is the area. General double integral is not an area. It's kind of some sort of a volume. Okay. Now, if I do triple integration, then if I do triple integration over some surface, what is this? Okay, just think dx, dy, dz, that is volume. And this is function. So what is above volume? Now you are jumping into a very weird sense known as fourth dimension. I'm not talking about time. That's a different story. In space, there is a fourth dimension. Guys, how many of you watched the movie Endgame? Avengers Endgame? In that, there was something like this mentioned, right? That is not infinity. Nothing to do with infinity. It is actually a fourth dimensional object known as Mobius strip. Mobius strip is just, you can make it at home. Take a line of paper, just one time twist it, then join the paper. You will get a Mobius strip. That does not make it fourth dimensional. But if I extend the surface of Mobius strip, that will become a fourth dimensional object. And that is known as Klein bottle. Obviously, we cannot make it because we are living in which universe? In a universe where there is only 3 dimensions for space. Our universe does not allow the 4th dimension. So tomorrow, if you are able to go and exist in the 4th dimension, how will you exist? That's a different story. But let's say you are able to exist, then you can see this 4th dimensional object. But whether you will picturize it, that's a different story. Because whatever images that your eye feeds, your mental processing is only for what? 3-dimensional. So you must be able to develop some special imaging techniques to develop what? 4 images. Are you getting my point here? So that's why it is never described in textbook. What is this? The reason is no one is going to understand this geometrically. Because 3-dimensional itself is tough. If I start to talk 4-dimensional, it completely jumps out of every. Because even I cannot show you. How can I show you? All things I can draw is either on the plane or on the space available. How can I show you for the 4th dimension? Okay, so physically I cannot show you, but there is a concept for that also. Now, how to make this into volume? Again, do the same process that you did earlier. Make whatever function is inside into what? 1. So this becomes a volume function. Check. To see the visualization of this 4th object, I think so YouTube, there are some images, animations. Just go and write about Mobius strip and Klein bottle. The 4th dimensional object is Klein, K-L-I-N-E, Klein bottle. Okay, understood the case here? How this works out? Now with problem, I'll show you how to practically work it out. And problem also I will show you. I think so shared my notes, handwritten notes. Chemical group, you got it, right? So share with all the chemical friends. He was actually with branch? Instrumentation. Don't worry, in the evening now, I will give it to some people so you can share among yourself. So please take that notes. The reason is I don't have time to describe all the notes. So I'm just giving you the main topics. But in my notes, everything is very detailedly mentioned. That is purely gate notes. So please go through that. Okay, not an issue, right? That's the reason why I'm not giving the detailed explanation of this. Okay, let's come back to the next case. What is that? How to do the problem, right? Let's start with some problems. Yeah. Let's say question number 173. Question number 173. The volume enclosed by a surface f of x comma y is equal to e raised to x over the triangle bounded by the lines x equal to y, x equal to 0 and y equal to 1. Okay, whenever you hear the question and whenever especially you hear the term, people have a misconception that we have to start with triple integration. Never do triple integration unless and until you have a z variable available. In that question, reading the question, do you have z variable available? No. That's the reason why I told you that double integral can also be volume if you include what? F of x comma y. If you neglect the function, then only it becomes an area. Otherwise, it's technically, ideally is what? Volume. So this is not triple integration. This is double integration problem. So this is what is the difficulty in this kind of a word problems. In word problems, the first conclusion that you must arise is whether you should do double or triple. I mean, now in perspective of gate, 90% of the times you are going to do double. So if you are not able to judge that, start with double. If you are failing with double, then go for triple. Although this will consume a lot of time, we can still attain that. 90% of the probabilities for what? Double integration. Triple integration are very, very rare problems. This is relating to which exam? Only for gate. Don't apply this logic for your subjective or university exams. Okay, that is not valid there. Please understand what I'm trying to say. Okay, now let's start. So, function is e raised to x. That's quite clear. Now we have to define the area. This is where your geometrical skills are going to come into picture. Okay, tell me, what are the restrictions that are available to us? X equal to y. So guys, if I draw the curve, how is x equal to y lines look like? This is what is x equal to y line looks like. Okay, next, what is the next line? Y equal to 1. Y equal to 1 lines. Then x equal to 0. What is x equal to 0? Your y axis is x equal to 0. Y axis is x equal to 0. X axis is what? Y equal to 0. So I am enclosing in which figure? Area enclosed by na. So this figure is what you have to focus. Is this clear? Now guys, so I have to do integration, double integration. What is the function? F of x comma y e power x into dx dy. Now guys, let me show you how to operate this. So we found out the area, we found out this is the integration that we need to do. Next thing I have to define is how to define the limits. So how to define the limits is how you want to take the strip. There are two ways to approach this. Either you can take horizontal strip, either you can take vertical strip. Either you can take horizontal strip or either you can take vertical strip. Now when you take horizontal or vertical, which is beneficial, it depends on how the figure is. For this particular problem, both are okay. There is no benefit in either one of them. But sometimes the figure that you get is very complicated. So in that situation, some orientation will be far more useful. Here right now, there is not much of a benefit. So which strip do you want? Horizontal or vertical? Right now, this vertical. Horizontal, okay. This problem I do with horizontal. Next problem I do with vertical. So you can practice both of them. And you should practice both. The left hand side. So how to take the length is lower limit is the left hand side of the strip. Higher upper limit is the right hand side of the strip. If it's horizontal, always remember for horizontal strip, lower limit is left hand side because why x values is less where left, higher values are towards the right. That's why we take lower limit like left hand side, upper limit right hand side. Okay. So at lowest point where it is touching, x equal to 0 to x equal to what? This strip is not only here, it can be anywhere on the area. So I don't know which point it is touching, but I only know is it's touching some curve. What is the value of x in this curve? X equal to y. So this is the strip. Now sweep the strip. That is how to sweep the strip is horizontal. So sweeping will be vertical. Sweeping will be what? That is like this, something like this. So by sweeping like this, you will cover the entire area. So when you sweep, start from the lowest point, because in y, lowest point is at the bottom, right? So lowest point, what is the coordinate of this? 0. 0, comma 0. What is the coordinate of this? 1, comma. So what is the y value at the lowest point? 0 to what is the y value at the highest point? Always remember the outer limit should always be a constant. Okay. Now, next thing, listen here. Before writing, listen here. Inner limit can be a variable. There is no problem with that. I always first write the inner limit, then only I write the outer limit. I always write what? The inner limit, then only I write the outer limit. Inner limit is always designated by the length of the strip. Who is inner limit? length of the strip. Who is the outer limit? Sweep of the strip. That is, sliding of the strip is the outer limit. Sweeping of the strip. That is your outer limit. Outer limit should always be a constant. Outer limit should not be a variable. If it's a variable, you have made some mistake. Okay, is that clear? Now, once you write that, let's write down the formula. Outer limit is this outer integration. What is that? 0 to 1. Next, what is the inner limit? 0 to, what is the x value? Y. E raised to x. Now, you also have to preferably write the order. Who is the inner one? Inner one, which variable? To understand that, in the inner limit, which variable is not present? X is not there. In the inner limit, which variable is not present? X. So that is the case. So start with dx and then into dy. Here order is very, very important. If you change the order now, your answer will completely screw up. Okay, just go and randomly doesn't change the order. You have to be very careful. So how this actually operates is something like this. This will be first integration and then the outer integration. Please note this down. Finish writing. Can I go to the next part? I have to solve it. Okay, let's start. Okay. I am integrating with respect to it. So what is the derivative of integration of e raised to x? So here again, in partial derivatives, what is the logic that you used? If you are integrating a derivative with respect to x, you should treat y variable as constant. So here also, if there is y variable inside the function, treat that as a constant term. So since there is no y variable in this particular case, so this will be what? E raised to x is e raised to x. Limit is from where? 0 to y dy. If I substitute the limit, what do I get? E power y. E raised to 0 is 1 na? Do the integration with respect to y. Allah. Answer is e minus 2. Here there is no option. So calculator put e minus 2 whatever. Answer 0.718. That's the answer. Understood how to do this double integral areas? Now this is 174 is also sometime double integral. Double integral 0 to a 0 to y f of x comma y dx dy is equivalent to what? That is, this is a question of changing the order of integration. So here itself I will show you how to, what is the actual order, and I will show you how to change the order. Okay, so let's copy this question. Just copy the integral function. Write down the question number. Just copy that integral function. That's the needed. 0 to a 0 to y f of x comma y dy. 0 to a 0 to y f of x comma y dx dy. Please note that down, because I have to explain the original order, and then from there I have to also change the order. Okay. So 0 to A, then 0 to what? X or Y here?
0 to Y.
Now guys, what is the order of the strip? Again, see the inner limit. Which variable is not present? So it's a limit for X. So X is equal to 0 to X equal to Y. So if this is X, then what is the outer limit? Y. So Y is equal to 0 to Y equal to A. If I draw the graph of this, X equal to Y lines looks something like this. Y equal to A lines looks something like this. And then X equal to 0, Y is equal to 0 are here axis. So what is the region that is trapped here? This is the region, right? The same logic that we did in the previous problem, right? Now, inner limit is for which variable? X, na? The values are for X. X equal to 0 to X equal to Y. So this is for which variable? X. So if its inner limit is for X variable, that is the horizontal strip. Because I told you, inner limit is for which length of the strip. So if length is horizontal, X values, then it is horizontal. So the original function is horizontal strip. If I want, I can draw it here. So this is the horizontal strip, vertical strip. I want to convert this into strip like this. Now, how to make it vertical? Okay, let's start with the length. Y direction, where is the smallest length? Bottom. Highest length is at the top. So at bottom, where is the strip touching? X. It is touching the inclined line, na? So y is equal to X to Y is equals to what? A. Now, what is the outer limit? What did I say regarding the outer limit? Sweep the strip. What you will do is sweep the strip. If I sweep the strip from left to right, because horizontal lowest value is left, highest value is right. So if I sweep at left, what is the point? 0. If I come here, what is the point? What is this? A comma A. The canon, this is X equal to A. So the outer limit is going to be, this is y value. So outer limit is X is equal to 0 to X equal to A. Now, what is the integral, double integral function going to look like? Write down the outer limit first, 0 to A. What is the inner limit? X to A, right? X to A. Next, a function will remain as it is. There is no change in the function. But the way in which dx and dy is written, that will change. Inner is for y, na? Inner is for y. So you have to write dy first, then dx. So see the option which matches this case. See the option which matches this. Which is option? So 0 to A, X to A, f of x, y, x comma y, dy dx. Understood? So understood how to change the order of the integrations? Guys, any doubt here? Understood how to convert from one strip to another? So with this, we are actually able to solve the vertical strip also. I told you how to handle the vertical strip. Yeah, 196. Question number 196. Please do question number 196. The first challenging part is what is this disk that is there talking about? X plus y, the x plus y square is less than or equal to 4. So it's area inside the circle, right? How does x square plus y square equal to 4 looks like? It's a circle with center at origin. Okay, guys. Whenever such figures are given, there is actually a shortcut. So what I was trying to say? When such figures are given, there is actually a shortcut. See, you can take either the entire diagram or you can take just 1/4 of the diagram, which is your positive coordinates, and from there you can evaluate it. Okay. By taking 1/4 of the diagram, the problem is you are going to get only 1/4 of the value. So you have to then multiply by what? 4. You have to multiply by what? 4. The same logic is also sometimes used in sphere, but in sphere the difference is it's a 3-dimensional figure. So how many? 8. Sphere, when it's divided by the 3 axes x and y and z, it is divided into 8 parts, not 4 parts. Circle is divided into how many parts? 4 parts. Are you getting my point here? So that's how the logic works. So let's try to do by the shortcut. So let's start with, since we did previous problem in horizontal, let's do the problem in vertical. So the strip will be vertical strip. Now, tell me, start with the length of the strip. What is y is equal to 0 to, what is the y value? See, y should always be an inner variable, so variable. No. X square plus y square equal to 4, right? This is my circle. So what is y? Actually, there are plus or minus, but in this, since I am taking only the positive value, I will be taking only which root? Positive root. So y is equals to, okay, next, x is equal to 0 to, x is equal to what? If I sweep the strip from x is equal to 0, if I reach here, what I am going to get? X value 2. Now substitute and find the answer. Substitute and I gave you the limits now. Just do the double integration. The first integration is with respect to dy, then dx. What's the confusion? Are you getting any complicated function? First integration is okay. After first integration, you are going to start to get some complicated functions which are not even integrable, right? Right? It's very difficult to integrate. Okay, you can do it actually, but it will consume at least half an hour in solving that. Okay, so there is some other way to work it out. And this is what I'm going to show you is known as coordinate conversions. Now, why this coordinate conversion I'm going to prefer? I normally don't prefer this, but right now I'm going to prefer that. It's because of this function. Where is that? Yeah. What is this function? Circle. For circle, the best coordinate system is polar coordinate system. What is the system? Polar coordinate system. So let's go for that. Since we are getting tedious function, we are going to change the logic and when we are going to rework the problem. In polar coordinate system, a point is located. How is point located? In Cartesian system, how do you locate a point? This is your x-axis or the x coordinate. This height is your y coordinate. Okay. In polar system, a point is located like this. This is the radial distance and this is the angle of this radial distance with respect to x-axis. So using r comma theta. This is the conversion from x is equal to, that is we want to convert from Cartesian to polar, replace x by what? R cos theta, y by what? R sin theta. If you want to reconvert it back, now only this is not sufficient. Replacing x and y is okay, but we also need to replace dx and dy. So dx dy in Cartesian system works out as r dr. Okay, tell me the integral function, please. X square plus 10 into dx dy. X square or x? X na? X plus y plus 10. Okay, now what I'm going to do is how to convert this into Cartesian, right? I'm going to replace x by what? R cos theta plus r sin theta plus 10 into, this was dx dy. What is dx dy replaced as? R dr d theta. Please note this down. I have to go to the second page. Please note this down. When polar, polar the logic is totally different. Horizontal, vertical. We will take radial strip. I'll show you how to take it. That's what I'm going to show in the next page. Here strip not horizontal vertical. That's a different logic, huh? Because we have changed the Cartesian coordinate system. In Cartesian, you are getting distance as x and y. So those are horizontal and vertical. That's why we used to take the strip as what? Horizontal vertical. Here I am going to take a radial strip. What strip? Radial strip. I'll show you, don't worry. At least finish writing this down. Can I go to the next page? Okay. So what was our equation? What was the curve? X square plus y square is equal to what? Less than or equal to 4 or it's almost 4. Here the strip is like this. Here the strip is radial in length. Okay, sure. So guys, tell me, R is varying from where? Origin means 0 to R is equal to what? What is the radius of the circle? 2. Now, since I want the entire circle, theta is starting from 0 degree to theta is equal to what? Take it as always in radians to 2 pi. Don't take it in degrees. Don't write 360 degrees. So theta is varying from 0 to what? 2 pi. Now, what I normally do is I take the inner limit as R, outer limit as theta. Because theta is quite difficult to manage. It's an angle, right? Whereas R is a length. So length is quite easy to manage. So I do what? Take the R as inner limit and theta as what? Outer limit. So 0 to 2 pi outer, 0 to 2 inner. So what was the function when we substituted that? R cos theta plus R sin theta plus 10. Into there is an outside function R dr d theta. Please first of all multiply this R inside. So when I multiply R inside, what do I get? R square sin theta plus R square, R square cos theta plus R square sin theta plus 10R into what? Dr d theta. Right? Now do the integration with respect to R. Can I do it in the next page? Can I both of? R square into cos theta. What is the integration of that? R cube by 3. Next, R cube by 3 sin theta plus 10R square by 2 is what? 0 to into what? D theta is remaining. Na? Now apply the limits R is equal to 2. If I apply R is equal to 2, what do I get? 8 by 3 cos theta plus 8 by 3 sin theta plus what? R square, that is 4. 5 into 4 is what? Now substitute d theta. What is the integration of cos theta? Sin theta. Integration of sin theta is minus cos theta plus 20 into what? Limit is from where to where? 0 to 2 pi. If I put 2 pi sin theta is 0, na? So this term I don't have to focus. Cos 2 pi is what? 1. So this will be minus 20 into 2 pi is what? 40 pi. That is the upper limit. What about lower limit? Again 0, sin theta is 0. Cos theta is 1. So minus of minus 8 by 3 again. Then 0, that term again 0. So lower limit only minus 8 by 3. So 8 by 3 gets cancelled. Na? So answer is what? Now remember, there is actually one term that I forget that. 1 by 2 pi. I didn't take that. So if I take that also, 1 by 2 pi into 40 pi, the answer that I'm going to get is what? Understood how easily we solve? So why polar system is beneficial here? Because the domain is circle. What is the equation of circle in polar coordinates is r equal to 2. If you want the equation of circle, what is the equation of circle in polar coordinates? R equal to 2. What doubt? Anyone doubts? I felt someone called me, right? Clear? Any issues here? Understood how to handle polar coordinates in double integrals? This again, the region is already given in the diagram. Here, which strip will you take, horizontal or vertical? Question number 216. Don't draw it, do it at home. I will send you the key also. Which strip should we take? See, students, if we take horizontal strip, what is the problem? While taking the strip, there is no issue. While sweeping, you come across an issue. What is the issue? See, left hand side, from here to here, it is inclined line. But from here to here, it is what? Vertical line. So you'll have to divide. You can do it still. What you have to do is divide into two different parts. Find the area of this part separately, find the area of this part separately, and then do the integration separately also. And then add it up. Time consuming. So which is the easier one? Take a vertical strip. So how to check is whether the strip is good is when I sweep the vertical, is there any problem with the upper point and lower point? Are the functions changing? Are the functions changing? So better is upper strip. So sometimes based on the figure, you have to prefer one strip. That's the reason why I told you to learn both the orientations. Just what's the issue? Then function is given, you just have to do the same procedure. Can you do that, right? I'm not again repeating the same thing. It's very lucky that you're getting figure. Very rarely do you get the figures. I'm trying to find this. I'm not getting that problem now. Actually, there's a gate problem, and that's what I want to show you. Not. Ah, yeah. Then only you get a detailness. This note's also sufficient, but also learn that. $52. Yeah. Guys, question number 52. Now the benefit with triple integration is, if it is asked, very rarely is asked, but if it is asked, it's a very straightforward question. The only thing you have to do is properly do the order of integration. So see the question. The volume of an object expressed by the spherical coordinates is given by 0 to 2 pi, 0 to pi by 3, r square sine phi dr d phi d theta. So what is the order? Inside is r, obviously. 0 to 1 stands for what? R. 0 to pi by 3 and 0 to 2 pi stands for which function? See, spherical coordinate system, there are two angles, phi and theta. So go for first phi, then go for theta. Go for what? First phi, then go for what? Theta. So please do it, try to work it out. Functions, everything is given. And how to realize this is whether should I go for phi or theta. Let me give an understanding of that also. Here, this sine function that you are seeing now, that is actually a conversion idea. Okay, so what is that? How the conversion works is dx. See, your Cartesian coordinate system will act like dx dy dz, right? That dx dy dz in spherical coordinate system, this is which system? Spherical, is r square into sine phi into d phi into sorry. So always remember, this sine phi function is connected with the inner angle. Theta is the outermost angle. So this is the order. Innermost is the r. Then next order is always see which is the angle connected with the sine function. So that is the second angle. Okay, that is the inner angle. And then the outermost angle is the which has no connection. That is theta. Or the idea. So this is how the order of integration is developed. This is what is this thing. Now, guys, in my notes, I have showed you how to convert this. The reason I am not discussing that right now here is it will consume a lot of time. So notes I have given that. So please go through the notes. If you are not able to understand it, tell me. I will send a separate video for that, explaining this in detail. But the problem is that is not rarely asked. This is the rare questions. So that's why I'm not focusing much on it. Okay, let's start. Can we do the integration? What is the integration of sine minus cos? Cos pi by 3 is what? 1 by 2. So minus 1 by 2 minus 1. Minus 1 by 2 minus of minus 1. So this is 1 minus 1 by 2. What is that? 1 by 2. So 1 by 3 into 1 by 2 is what? Then what is the integration of theta? So answer is 2 pi into 2 pi divided by 6, which is, that's it. At the max, I think so 4 or 5 times they have been asked. Triple integration. So that's the reason why I told you that 90% probabilities for what? Double integration. In double integration, there are two types of questions that is mainly asked. One is, three types. That's what I showed you with each and every problem. One is your straightforward double integral. Function will be given, the area will be given, or they will find the question in terms of area. They will ask you to find the question of area between some curves. So all these things are double integrals. Next, changing the order of integration is the second type. This is bit rare. And the third type is what? Polar coordinate conversions. That is normally asked. Okay, that is always coming together. So these are the three types of problems that you see in gate examination. So understood the multiple integrals? Any issues here? Understood. Now you have to develop the practice of drawing the areas. So do maximum problems with drawing the area, and from there start to develop the strip idea. Okay. Next topic, the smallest topic that we have to cover is Taylor series and Lorentz series. Taylor series and Maclaurin series or Lorentz series, sometimes also known as Maclaurin. Let's first start with Taylor series. Okay, what does the Taylor series say? What is the last term going to be? This actually goes up to infinity. So there is a very difficult to define the last term. This is the infinite series of Taylor series. So what is happening here? Any random function I am converting into a pure algebraic infinite series sum. Any random function, but about which point? About the point A. About which point I am converting this into algebraic function? About the point A. This is what is Taylor series. So that is the benefit of Taylor series. Any random function can be converted into infinite series of what function? Algebraic function. So he actually, because the reason why we are focusing on algebraic function, or why Taylor focused on algebraic function, because functionally speaking, which is the easiest function to handle? Trigonometry, exponential, algebraic, or your logarithmic? Algebra is quite easy to handle. That's why we are going for that idea. That's why Taylor also tried to convert this into this. But when he was designing this, the only thing that he was able to design was infinite series. Although it's not a complete solution, it gives you some sort of an approximation. Got this idea? Now what Maclaurin did is, he defined this on the point A is equal to 0. So Maclaurin series, or sometimes also known as Lorentz series. See, Mc is kind of a title, man. Have you heard about McDonald's? So in English language, they also call it, that person is, if someone's name is McDonald or any other What's the other name? There's a famous whiskey for that, McDowell. But any other name, that's what I was thinking. Okay, whatever other people's name are there. Mek is kind of like Arabic people use the al. Have you heard the term al? Al is kind of like a title, the. Or English people, instead of Mek, sometimes they also use the term sir, S-I-R. Okay, so those are actually titles. So you can remove the titles and call the person as the same also. So in some textbooks, McLaurin is also called as Laurent. They are same person. So once you define this on 0, what happened? F of x will become what? F of 0 plus x by 1 factorial into what? F dash of 0 plus x square by 2 factorial into f double dash of 0 plus, like this it will go on up to infinity. This is what is your Taylor's and Lorentz series. In my notes, I think so I discussed Taylor series in derivatives. It's not a separate topic. In my notes, it is discussed in the heading of what? Derivatives. Please go through that. Is this okay? Now I will show you how certain series have come into picture. You might have heard about e raised to x, right? I will show you right now how it came. Let's see. Let's draw the e raised to x series about what? Since I'm taking about x equal to 0, which series will I do? Which series will I take? Maclaurin series. So f of x is what? E raised to x. F dash of x is what? E raised to x. F double dash of x. E raised to x. Like this it will go on. So tell me, what is f of 0? F dash of 0. F double dash of 0. So like this it will go on. Now what is our Taylor Lorentz series? F of x is equals to, first, f of 0. What is f of 0? Plus x by 1 factorial into f dash of 0. What is f dash of 0? 1. So no need of writing into 1. Plus second derivative is what? X square by 2 factorial into second derivative is 0 at 0. What is the value? Again 1. So like this will go on. Next term will be what? X cube by 3 factorial into f triple dash of 0. What is that? Again 1. So like this will go on up to infinity. This is what you have studied famous directly by hearted in your 11th and 12th. In 11th and 12th, they never explained you how we got this. Because you have not studied Taylor's and Lorentz series in the 11th and 12th. You are studying that in your BTech life. So this is how we actually proved it out. So what I want you to do is right now prove it for sin x and cos x. Take f of x equal to sin x and cos x. Start with sin x. Take f of x first with sin x. Start with sin x, please. So again, start with f dash of x, f double dash of x. Like that, please find the answers. F of x is sin x, f dash of x is cos x, f double dash of x is minus sin x, f triple dash of x is what? Minus cos x. Find up to f6 dash. You will realize later why I am finding up to 6th derivative. Please find up to how many derivative? 6. Somewhere it will become 0. Now put x is equal to 0 in all the 6 derivatives. After finding 6 derivative, let me tell you one by one the derivatives. F of x is sin x, f dash of x is cos x, f double dash of x is what? Minus sin x, f triple dash of x is what? Minus cos x, f4 dash of x is what? Sin x, then again cos x, then minus sin x, right? Now put the value 0. F of 0 is what? 0. F dash of 0 is what? 1. F double dash of 0 is what? 0. F triple dash of 0 is minus 1. f4 dash of 0 is again 0. Fifth derivative of a function is what? 1. Sixth derivative is 0. So, in the Maclaurin series, this term is 0, second derivative is also 0, right? So, what are you going to get? Sin x will be equal to what? X by 1 factorial. Next, third derivative is what? What is the value of third derivative? Minus 1, na? So, minus x cube by 3 factorial. Next, what is the fifth derivative? Again, plus 1. So, plus x raised to 5 by 5 factorial. Next term will be seventh derivative, which I have not taken, it will be minus. So, like this will go on. Similarly, try for cos x also. What's the case? 1 minus x square by 2 factorial plus x raised to 4 by 4 factorial minus x raised to 6 by 6 factorial. Like this it will go on. So it's quite easy, right? This is what is Taylor series. Now let's see some gate problems. Yeah. Question number 88. 88 and 88, both you have to do. Let's start with 88 first. Which of the following function would have only odd powers of x in its Taylor series? Which of the following function would have only odd powers of x in Taylor series? Now guys, how to know that is, I worked out for you sine and cos, right? So which function had odd power? Sine. So obviously the option is either A or B, because cos can never have an odd power. Because even if the inside function is x cube, what will happen if I substitute inside that is cos x, if I design that as x square, so x cube square is what? At a cos x we designed that as 1 minus x square by 2 factorial. So for cos x cube, all you have to do is replace x by what? X cube. So then substitute, if you're taking x cube square, what is the function? X raised to 6. X cube raised to 4. That is x raised to 12. So it is always going to give an even power. So cos is never going to give you odd powers of x, whether x power is odd or even. It is always going to give you the expression as even powers of x. What about sine? Sine can give you. The only way sine can give you odd powers is the inside function of sine is odd power. Okay. So all you have to do is, first of all, write sin x, please. Please write sin x. Expansion of sin x. What is sin x equal to? X minus x cube by 3 factorial plus x raised to 5 by 5 factorial, like that it will go on. Now replace x by x cube in each and every term, both the sides. Replace x by x cube. Why are you writing f of? That is for Taylor series. What are you getting? X cube by x cube minus x raised to 9 by 6 3 factorial plus x raised to 15 by 5 factorial. Are you getting something like that? That is sin x cube. So our question is, which is the odd power? Only sin x cube will give you odd power. Next. Now here in question number 89, you have to expand e raised to x plus sin x about x equal to pi. Let me show you. So what is f of x? E raised to x plus sin x, and I am expanding about which point? Okay. So you got f of x, you got the logic. What is the Taylor series? F of x equal to f of a plus x minus a by 1 factorial into f dash of a plus x minus a by square by 2 factorial into f double dash of a. Like this it will go on. All you have to do is replace x by what? Pi. So before doing that, f of x is what is f of f dash of x? F double dash of x, e power x minus sin x. Next, f triple dash of x, e power x minus. I think so. This will be sufficient. If not, we'll let's check later on. Okay, f of pi. What is f of pi? What is the question actually? We just need to find coefficient of x minus pi the whole square. Okay. So I don't need everything. I just need a specific term. Now guys, x minus pi the whole square is going to come in this format. Right? So who is the coefficient? This. So write down. So I don't want everything, I just want this particular case. So coefficient of x minus pi the whole square is equals to f double dash of pi divided by 2 factorial. Okay, now f double dash of x is already known. What is f double dash of pi? Let us replace x by pi. E power pi, sin pi is what? 0. So no need of writing that. So e raised to pi divided by 2 factorial or e pi divided by 2. That's it. This is the coefficient of x minus pi the whole square. Any option like that? Let's see. 0.5 e raised to pi. Right? Get out. So understood how to handle Taylor series, Lorentz series. Let me go for another problem. Huh? മനസ്സിലായില്ലായിരുന്നു അല്ല ഇത് അയച്ചിരുന്നുണ്ട് ഇവര് question number 103. Now this is a tricky problem. That's why I specifically selected that. In question number 103, don't take f of x as sin x divided by x minus pi. Don't take f of x equal to what? Sin x divided by x minus pi, because if you start to take derivatives of those functions, you have to apply the u by v rule. Instead of doing that, let me give you another idea. Take f of x equal to sin x. And about x equal to pi, please define the Taylor series. Now, please don't put this in Lorentz series, because Lorentz series is defined at x equal to which point? 0. So, Lorentz series is not applicable here. So, I cannot go by that shortcut. I have to properly work out the Taylor series of sin x at about which point? X equal to pi. Please do it. Understanding? No? Sin pi minus 1. Are you getting something like this? Minus x minus pi divided by 1 factorial plus x minus pi the whole cube divided by 3 factorial minus x minus pi divided by raised to 5 to the power of pi factorial plus x minus pi divided by raised to 7, not 5, raised to 7 divided by what? 7 factorial. Like this it will go on. Okay. Now this is for actually which function? Our requirement is for which function? Now divide by x minus pi on both the sides. So what will happen here? Minus 1 plus plus x minus pi the whole square divided by 3 factorial minus x minus pi the whole raised to 5 divided by 4 divided by 5 factorial. Like this, every time one power will reduce, na? Dividing by x minus pi on both the sides. On the right hand side, each and every term, one power will reduce. So why did I do this? Is because I know that Taylor series expression is always going to be in which format? X minus pi. That's why when I saw in the original function x minus pi, I neglected that. I expanded for sin x and then I divided by x minus pi on both the sides. So sometimes you have to be careful with the functions that are given to you. Because you directly take the function, it will be very, very long method. You will get the answer, same answer, but it will consume a lot of time. Because you are going to waste a lot of time on derivatives. So never directly jump, sometimes see the questions and then adjust the questions accordingly and then jump. Are you understanding my point here? So I took for sin x and then I divide by x minus pi. So this is what is Taylor series. Now let's go for the last special topic. What is the last special topic? Okay. This is actually not have been asked, but as a worst case scenario, we are discussing it because it's a part of topic. Okay, in my notes, it is discussed as just one part in the last section of multiple integrals. Okay, so let's start. So write down beta and gamma functions. Write down the first heading, the gamma function. Write down the first heading, gamma function. The general topic is beta and gamma. Write the first function, gamma function. Gamma function of n, this L, writing L in an opposite manner is known as gamma function. The gamma function of n is 0 to infinity e raised to minus x, x to the power of n minus 1 into dx. Okay, now write down. When n value is 1, the value of the integral is 1. When n value is 1, the value of integral is what? 1. When n value is half, the value of integral is root of pi. Just learn these two values and then we are going to use a famous property. The property goes like this. Gamma n plus 1 equal to n gamma n. Now, people might be asking where this is regularly used. Now, guys, this is mainly used in a topic known as Laplace transform. Okay, let me explain this idea. Laplace transform of t raised to n. Okay, EC civil students, EC electric students, tell me, what is Laplace transform of t raised to n? N factorial divided by s power n plus 1. Provided n is what? N is but if n is not a positive integer, okay. Now in gate examination, in Laplace transform, there was one question, and this was asked for every branch, not for only for EC electrical. Although this topic comes under that, this was asked as a gate question. Let me tell you what was the gate question. The gate question was, find Laplace transform of t raised to 3 by 2. Laplace transform of what? T raised to 3 by 2. Now this is the formula for Laplace transform when n is what? Positive integer. Now this 3 by 2 a positive integer. 3 by 2 is not an integer value, right? It's not an integer, but it's still positive value. Again, n should be positive, then only it's defined. Okay, so it's positive. So I can actually apply the second case. So the correct answer of this is second case. So what I have to do is gamma function of what? 3 by 2 plus 1 divided by what? S raised to 3 by 2 plus 1. So the challenge here is denominator is okay. As 3 by 2 plus 1 is what? 5 by 2. Na? What about that gamma function? How will you handle that? That's where I'm going to use these properties. These are the main properties of gamma function. So, see, the value that I know is gamma function of 1 is 1. Gamma function of half is what? Root 2. And also I know one more thing. Gamma function of n is n factorial if n is what? That is, if I ask you gamma function of 2, what is gamma function of 2? 2 factorial. Gamma function of 3, like that it will go on. Oh, sorry, gamma function of, that's what I was. N plus 1 not n factorial. Sorry, my mistake. Gamma function of n plus 1 not n factorial. That's where I had a doubt. Because if that is the case, then 0, how will I define? That's when I was thinking. Okay. So always remember gamma function of n plus 1 is what? Because that's how it is similar, na? See here. That is okay. Huh? No, this is okay. Yeah. But here the problem is, this is normally used when n plus 1 can be taken as what? Integer value, non-integer values. Integer values is quite difficult to challenge. Okay. Are you getting my point here? Okay, let's work it out. Because this is a weird function, this complication comes. Just focus on this. So is this much clear? Now let's start with the case. So gamma function of what I want to find? 3 by 2 plus 1. So according to the rule, what is the rule saying? Gamma function of 3 by 2 plus 1 according to this rule, what is saying? Is 3 by 2 gamma function of 3 by 2. Again, I know the value of 3 by 2. What value I know? 1 by 2. So how to replace that again is do the same property. 3 by 2 can be written as 1 by 2 plus 1. Right? Now what can this become? 3 by 2 into what is n? 1 by 2 into gamma function of 1 by 2. Now 3 by 2 into 1 by 2 to gamma function of 1 by 2 is what? Root pi. So what is the answer going to be? 3 root pi divided by what? So this is the value of this gamma function. N value is what, man? So 1 by 2 into gamma function of 1. That plus 1 is the separate part. This plus 1 always gets vanished. Always remember this, plus 1 always gets what? Vanished. So what will be the answer of this Laplace transform finally? 3 root pi divided by 4 into s raised to what? Pi by 2. Okay. This was asked once in gate examination. I don't remember. It's either for EC or electrical. For you people it was asked. Okay. So how this works out is gamma function. Is it clear? Next. So understood what is the gamma function, right? Now, beta function. Beta function. Beta and gamma function. So you have to go for the next function, beta function. Or beta, whatever way you want to pronounce. The actual pronunciation is beta, not beta. Beta is the Indian mispronunciation of the word. It's beta actually. Okay, forget it. That's not the important case. We are not English people. Okay, we are Indians, so we can mispronounce it as we want. Okay. So beta functions. 0 to 1 x raised to m minus 1 into 1 minus x into x raised to 1 minus x to the power of what? N minus 1 into dx. Now, beta function of m comma n, if I replace that by n comma n, they are one and the same. That is, if you change the powers, it doesn't make any difference in the values. That is, if n minus 1 power is taken here and m minus 1 power is taken here, it doesn't change the value of the function. Please listen. Next thing, beta function and gamma function are related. Please note that down. Beta m comma n is gamma function m multiplied by gamma function n divided by gamma function m plus n. Algebraically, there are different versions of beta functions. It can be x raised to m minus 1 into 1 minus x to the power of n minus 1. Same beta function in other ways can be written as x raised to m minus 1 divided by 1 plus x to the power of m plus n. Even you replace n minus 1, the same logic comes. This is the benefit, because beta functions can be interchanged. You write it in m, you write it in n, are one and the same things. Okay, this is the algebraic version of beta function. There is trigonometric version also. Let's write that down. This is the trigonometry question. Sine raised to the power of 2m minus 1 and cos to the power of what? 2n minus 1. Even if we interchange it, this does not make a difference. If 2m minus 1 goes on the cos, interchanging it does not make a difference because beta of m comma n is what? N comma m. So replacing does not change the difference. So understood the idea? This is what is beta function. Now let me give you some problems. Let me quickly finish it up. Just 5 minutes. Solve, write down. Solve x raised to 7 into 16 minus x raised to 4 to the power of 10. Now, whenever you see such questions, you will start to expand. The problem is the expansion is in which power? 10th power. So, if you write the terms, there will be 11 terms in that expansion. If you apply the binomial theorem, there will be how many terms? 11 terms in the expansion. Now, we have to multiply that x raised to 7 by all these 11 terms, and then only you can do the integration. Now, there is a cover up to this. So, how to do that is, now, beta function can be applied here. How to do that is, replace this x raised to 4 by some variable. So, let x raised to 4 equal to t. So, what is the differential? 4x cube dx is equal to dt. I have x cube in the form of x raised to 7. So, out of that, there is some x cube, I can take it out. So, what is x cube dx technically? Dt divided by 4. Now, I will show you what happens to the integration. If I replace this 0 to 2, let us keep it like that. I said whenever I substitute, I don't change the limits. Keep it like that. But I am doing with that now. So here I have to change the limits. I cannot do that idea because I am going to operate it on what? I am not going to do the actual integration. I am going to do the beta functions, right? So I have to change the limit. Okay. At x equal to 0, what is the value of t? 0. If x is equals to 2, what is the value of t? 2 raised to 4. What is 2 raised to 4? 16. Now, x cube is going with dx, but how much is remaining now here? X raised to 4, na? In x raised to 7, x cube is going with the dx to convert into dt. How much is remaining here? X raised to 4. What is x raised to 4? Into bracket 16 minus t to the power of what? 10. 10, yeah. Into what? dt divided by now. What is the beta function idea? Beta function of n, please tell me. What is beta function of n? Beta, sorry. Beta function of m comma n. What is beta function of m comma n? What is the original definition? Integral 0 to 1. Just hang on a minute. Okay, so this is not 0 to 1. How to do that? Let's do one thing. Let's change the substitution. X raised to 4, let's write down as 16t. X raised to 4, let's write it down as what? 16t. So, 4x cube dx is equal to what? 16 dt. So, what will happen? Four divided, so I will get 4 dt. The problem is I need the limit from 0 to 1. I am not getting that. So that's why I did this. Now what is the benefit here if I take 16 dt? This when x is 0, 0. When x is 2, what will happen to t value? 2 raised to 4, 16 divided by 16. So what is that? Now let's replace this. Now what is this? X raised to 4. X raised to 4 will become what? 16t into bracket 16 minus 16t to the power of 10 into what will happen to dx or x cube into dx? 4 dt. Now 16 is already here. 16 coming out of 16 raised to 10. What is that going to be? It has 16. If I take it outside the bracket, it will be 16 to the power of 10 into one more 16. What is that? 16 to the power of 11. So 4 into 16 to the power of 11. Let's keep it like that. Into 0 to 1. T into 1 minus t to the power of 10 tt. Okay, guys, tell me beta function of m comma n. What are the definition? 0 to 1. What is that? X to the power of what? M minus 1 into 1 minus x to the power of into what? Dx. This was the case. Now here I have to do some adjustments here. Let me show you the adjustments. T to the power, instead of writing 1, write it as t to the power of 2 minus 1. What about 1 minus t? How to write that? 11 minus 1. Is there any problem with that? Kana 11 minus 1 is what? 10. Now this is gamma beta function of what? M. So beta function of 2, beta function of 11. So finish writing up to here. Now I'm not doing a conventional way of integration. I'm completely changing the way of integration. That's why I've written like this. Okay? Didn't understand. Huh? Repeat this step. Because I want to convert this into this idea. So what is the actual power? 1. 1 is 2 minus 1. No? Because I want to convert similar to that. Similarly, what is the power here? 10. But I want to write it about how to write it. N minus 1. So 10 can be written as what? 11 minus 1. Now this is clear? Okay, let's go. So finally, I is what? 4 into what? 16 power 11 into beta function of what? Now guys, beta function of 2 comma 11 was what? See, I told you beta function directly doesn't have an answer. If it's an integer, you can directly convert it to gamma function. So it's what is that? Gamma function of 2, gamma function of 11 divided by gamma function of 2 plus 11. So gamma function of 2, what is gamma function of 2? Get a gamma function of n plus 1 is n factorial. So gamma function of 2, that is 1 plus 1. What is that? 1 factorial. Let me repeat again. Gamma function of n plus 1, if it's an integer, is. So gamma function of 2 is technically what? 1 plus 1. Na? What about 11? 10 plus 1. So it is 10 factorial. Now 2 plus 11 is how much? 13. So that is 12 plus 1. That is 12 factorial. Now just simplify the powers. 2 square, 2 raised to 44. So 2 square into 2 raised to 44 is what? 2 raised to 46. into 10 factorial divided by, you can further simplify it as 2 raised to 46 divided by, what is 12 into 11? Or 2 raised to 46 divided by, I divided by 4, man. 12 is divisible by 4. So dividing by 4 in 2 raised to 46 is just reduce the power by 2. So 46 will become 44. Divided by 11 into 3 is what? Obviously, this can be found, cannot be found. Stop here. Okay, understood how to handle beta gamma function. So guys, this is the end of this. So guys,